Hello, welcome to Regal Achievers Educational. So we're going to continue from where we stopped the last time, whereby we are reviewing the paper one, Foundation Accurate Thesis, or for June 2018. So we're going to be looking at quite a number of questions today, and hopefully, maybe we'll probably conclude on this particular paper. So do well to get your notes and your pen to jot down as well during the course of the class. So the first question there says, the plug of an electrical appliance contains a fuse. Whoa, this is a very beautiful one. The plug of an electrical appliance. What is the correct circuit symbol for a fuse? If you take a look at all the symbols we have here, they are generally called the circuit symbols. But each of them have different circuits that they represent. They have different circuits that they represent. But basically, what the question is asking of us is the one that represents the fuse. And from the option here, the one that represents the fuse is the second one. So you just need to take the box, and there you go, just the one marker. Then the next question says, the appliance is connected to the main electrical supply. The appliance is connected to the main electrical supply, and the main potential difference is 230 voltage. Calculate the energy transfer when 13 coulomb of charge flows through the appliance, and you've already been given the equation to use. So basically, you just need to insert the value and you get your answer. So the charge is already given as 13, and the potential difference, which is in voltage, is given as 230. So basically, you just multiply the two together and you get the answer for your energy transferred, which is going to be 2,990. 2,990, which is in joules. And that is why you see the unit already is highlighted in the question. Then we have the next question. It says figure 9 shows the structure of a fuse. If you have maybe an electrical kettle, if you take your time to look at the power cord, you must have seen this particular. So they say write the equation that links charge flow, current, and time. The equation that links the charge flow, current, and time. So basically, is charge flow equals to the current multiplied by time. Charge flow equals to current multiplied by time, which is Q equals to I times T. So this is the equation that link all of them together. And if you remember from our last session together, I mentioned that whenever they ask you to write the equation that links something together, the next question often has to do with you calculating. So it says the fuse fire melts when 1.52 coulombs of charge flows through the fuse in 0.40 seconds. You have to calculate the current at which the fuse wire melts. Don't forget, the current here is the high, and they've already given you what? They've given you the charge flow, and they've also given you the time. The charge flow is measured in coulombs. So basically, you can just write Q equals to high T. And since you are looking for the current, that will be high equals to Q over T. Okay? And already we know that our Q is what? 1.52, and our T is already in seconds, which is 0.40. So if you do 1.52 over 0.40, that will give you 3.8 amps. It's as simple as that. Let's move on to the next question. The mass of the fuse wire is 0.00175 kilogram, and the specific latent heat of fusion of the fuse wire is 205,000 joules per kilogram. And you are asked to calculate the energy that is needed to melt the fuse wire. In this regards, you're going to be given the equation sheet to use. You're going to be given the equation sheet to use. And basically, all you need to do, because you are finding the specific latent heat, the specific latent heat is just the mass specific latent heat is always mass multiplied by the latent heat of fusion, and the mass is already given as what is 0.00175, and the latent heat of fusion is 205,000 joules per kilogram. So if you multiply that together, that will give you 359 joules, which is the actual specific latent heat of the fused wire. Okay, so let's move on. Let's move on. Let's move on. The next question, they say figure 10 shows a hot water tank that is made of copper. The first thing you want to do here, you don't rush to just go and answer the question. The first thing you want to do is to study the diagram. You want to study the diagram. That is the first thing you want to do. You study the diagram quite very well. You can see where the hot water passes out through. This is the tank. You can see the insulation. You can see the electrical immersion heater. And you can also see where the cold water actually passes in. Okay, then I say copper has a higher thermal conductivity than most metals. How does the rate of energy transfer through copper compare with the rate of energy transfer through most of the metals? Okay, since we already know that copper has a what? Higher thermal conductivity than most metals. They've already answered the question even from the description. So when they now ask you, how does the rate of energy transfer through copper compare with the rate of energy transfer through most metals? Since copper has a higher thermal conductivity, surely the rate at which energy will transfer through copper is going to be higher as well when compared to the rate of energy transfer in the case of metals. The next question then says, the tank is insulated. Aha! So when the water is hot, the immersion heater switches off on its own. Just like your normal water heater, when the water is hot, automatically switch off on its own. Then I say, complete the sentence. Compared to a tank with no insulation, okay, the rate of energy transfer from the water in an insulated tank is lower. Is lower. And this means that the water in the insulated tank, it will stay hotter for a longer time. It will stay hotter for a longer time. Okay, that is what it means. And we have figure 11 shows how temperature varies with time for water in a tank. Heated with an immersion water. Good. And figure 12 shows how temperature varies with time for water in a tank heated with a solar panel. Oh, we are doing a comparison here. So you can see from the diagram, from that figure, you can see the temperature of water in degrees Celsius. And at the same time, you can see the time of the day. And at the same time, if you look at that of figure 12, you can see that as well for the one of the solar panel. You can see the way the graph, okay, is being drawn compared to the second one. Now, let's look at the question. It says, give one advantage and one disadvantage of heating the water using solar panels rather than an immersion heater. Immersion heater is just like a boiling ring that you just put inside the water and to make the water to be very hot. So if you are to talk about the advantage of the solar panel, basically, because solar panel got its own source of energy from the sun. So that means the heating will be what? Continuously. So that means the water will be heated. Water will be heated continuously. That is the advantage because the source is sun. So water will be heated continuously. And one disadvantage of a solar panel, okay, is that the temperature of water is lower. The temperature of water is lower because for most of the time, than water heated by immersion of immersion heater. The observation there is that most of the time, because you're using the solar panel to actually heat the water, the temperature of the water is lower, and sometimes it takes longer to heat the water. I think I will even go with that. It takes longer to heat the water because you are using the sun. So it depends on the intensity of the sun as well. That determines how hot or how fast the water gets quite very hot. So I would say that the disadvantage could be that it takes longer. It takes longer to heat the water. It takes longer to heat the water. Good. Now let's move on. The next one says, during one morning, a total of 4,070,000 joules of energy is transferred from the electrical immersion heater, and 4,030,000 joules of energy are transferred to the water. Calculate the proportion of the total energy transferred to the water. The proportion of the total energy transferred to the water is the what? The energy transferred to the water over the total energy that is transferred from the electrical immersion water or immersion heater. That'll be 4030000 over 4070000. So you can simplify that. So that'll be 403,407. You divide it, and that will give you a proportion of what is 0.99. Let's move on. We are doing great. The next question says, write down the equation that links energy transferred, power, and time. Energy transferred, power, and time. So basically, that is going to be power equals to what? Energy transferred divided by time. Power equals to energy transferred divided by time. And like I said, the next question is surely going to be us calculating something relatively. So in this one, they say the power output of the immersion heater is 5,000 watts. Calculate the time taken for the immersion heater to transfer 4,070,000 joules of energy, and you have to give the unit in this regard. Okay, since you know that P equals to ET, and we are looking for T this time around, so basically that means T equals to what? T, you have PT equals to E, so that means T equals to E over P. Okay, so that means your E is what? 4070000 over P, which is 5,000. So if you divide this, that is going to give you 814, and the unit for time here is seconds. We are doing exceptionally well. Now take a look at this question. Figure 13 shows a lift inside what? Inside a building. Oh, some of you that have been inside a lift before, you'll probably be able to relate to this question quite very easily. It shows a lift that is present inside of a what? Inside of a building. Oh, and you can see those that are inside of it. Then I said the motor in the lift does 120,000 joules of work in 8 seconds. And you have to calculate the power output of the motor in the lift. They've already given you the equation to use, okay? So you just need to put the values right inside of it. So what do you just do? That will be what? 120,000 over the duration, which is 8. And that will give you 15,000 watts. It's as simple as that. Then the next question says, the power input to the motor is greater than the power output. Pick 2 reasons why this is so. The number 1 reason is that energy is transferred in heating the surrounding. This is one of the reasons. Energy is transferred in heating the surrounding. And secondly, friction causes energy to be transferred in non-useful way. This is the 2 reasons there. Figure 14 shows part of the circuit that operates in that lift motor that we just see right now. They say the lift can be operated using either of the 2 switches. We are asked to explain why. Okay, why is because if we look at the 2 switches here, they are in parallel. Okay, if you look at the 2 switches, you are going to see that they are in parallel. Okay, and if you close any of them, it actually does what? It completes the circuit, because the 2 switches are in parallel, and close any of them actually also complete the circuit. The next one says write down the equation that links gravitational field strength, gravitational potential energy, height, and mass. This is quite very simple. This is quite very simple, just like your potential energy. So that would be what? E equals to what? Mass times gravity times the height. And the next question, you just need to apply the same equation that they just asked you not quite long. So you have the lift goes up 14 meter. Ooh, that's the height. And the total mass of the people in the lift is 280 kilogram. That is the mass. And the gravitational field strength is given to you as 9.8 Newton per kilogram. You have to calculate the increase in the gravitational potential. Calculate the increase in the gravitational potential energy of the people in the lift, and you have to give your answer to two significant figures. So basically, you just need to multiply everything together. You just need to multiply everything together. You have your what? Your 280, you have 9.8, and you have 14. So if you multiply everything together, that will give you 38,416 joules. Since they ask us to put our answer in two significant figure, that is basically going to be what? 38000 joules. So as simple as that. Let's go on. Let's go on. Figure 15 shows a student that is walking on a carpet. Oh, that's amazing. So the student becomes negatively charged because of the friction between his socks and the carpet. Okay. So they say, explain why the friction causes the student to become charged. When we talk about electrostatic, this also gives you an idea about it. But basically from this question, why is because there is a transfer of electron between the what? The carpet and the socks. There's a transfer of electron, and that is why the student become charged. Okay, there's a transfer of electron between the carpet and the student. So from the carpet, there's transfer of electron to the student because there's also charges that's been released from the student. So that is the reason why the student becomes charged. Then we have the student head is represented by the sphere in figure 16. The student is negatively charged. The arrow shows part of the electric field around the student's head. We have to draw 3 more arrows on figure 16 to complete the electric field pattern. We have to draw 3 more arrows on figure 16, okay, to complete the electric field pattern. Since you already know that it is negatively charged, okay, you realize that the arrows will direct inward and it will distributed evenly around the sphere. So basically, we can have 3 arrows. We already have one already. So you can have 3 arrows. And they are going to be going inward. That means you have to show the direction. So this is just basically what you're expected to do. So just something related. They now say the negatively charged student touches a metal tap. Oh, and after touching the metal tap, he receives an electric shock. Explain why. And that is because there is a PD, that is the potential difference between the the student and the tap. Okay, and this will now cause electrons to be transferred from the student to the what? To the tap. Okay, or it can cause electron to be transferred from the tap to the student, and that is why the shock occurs. Okay, so we have the next one that says some carpets have thin copper wires running through them. The student is likely to receive an electric shock after walking on this type of carpet. Why? Because the carpet, okay, or the copper, that is the thin wire, there has a low resistance. Okay, and since it has a low resistance, that means it has a low, inbuilt of charges. Okay, there's low inbuilt of charges, and as a result of that, there is not much potential difference between the student and the carpet in that regards. All right, let's take a look at the next question, please. Let's say a teacher used Gauge-Muller tube and counter to measure the number of counts in 60 seconds for a radioactive rock. The counter recorded 819 counts. Wow. 819 counts in 60 seconds. The background radiation count rate was 0.30 counts per second. Calculate the count rate for the rock. This is quite very simple. To calculate the count rate for the rock, that is just, simply 819, the one that has been recorded, over the 60 seconds over 60. Okay, and that will give you 13.65. And if you look at it, when they say the background radiation count rate is what? Is 0.30 count per second. So the actual corrected count rate, you just need to subtract negative 0.30 from this, and that will give you 13.35 as what? The correct count rate. They say a householder is worried about the radiation that is emitted by the granite worktop in his kitchen. Okay, then I say 1 kilogram of granite has an activity of 1250 BQ. The kitchen worktop has a mass of 180 kilogram. Calculate the activity of the kitchen worktop in BQ. All right, so basically here it's quite very simple. The activity of the worktop, so what you just need to do is what? 1250 multiplied by this, by 180, okay? And that will give you the activity to be 225000 BQ. All right, the next question there says, the average total radiation dose per year in the UK, 2.0 millisievert. And the table 2 shows the effect of radiation dose on the human body. You can see the radiation dose in millisievert, and you can see the effect as well based on the measurement. And the average dose from the granite worktop is 0.003 millisievert per day. Explain why the householder should not be concerned about his yearly radiation dose from the granite worktop. 1 year is 365 days. So basically, since they have given us the average radiation dose from the granite worktop in a day to be 0.03, so that will be what? 0.003 multiplied by 365. Okay, if you do 0.003 multiplied by 365, the answer you get is what? It is less than 100. Okay, which is the what? Which is the lowest dose with evidence of causing cancer. So since the answer we've gotten is less than 100, so the person might not have to actually be consigned in the yearly radiation dose from the granite workshop, because he or she might not actually be predisposed to the symptoms. Then the next one says bananas are a source of background radiation, and some people think that the unit of radiation dose should be changed from sievert to banana equivalent dose. That is the BQD. They say, so just one reason why the banana equivalent dose may help the public be more aware of the radiation risk. Why? Is because people are able to compare radiation risk or dose or hazard to the radiation dose from eating banana, because they can relate to it quite very well, because we're talking about what they consume. So they can relate to it even much more better. So we have I think this is the last question. It says, a student investigate how the resistance of a piece of nichrome wire varies with length. Figure 17 shows part of the circuit the student used. So the first thing you want to do, you study the circuit. That's the first thing you want to do. You don't want to just rush to go and answer it. You study the circuit. That's the first thing you want to do. Okay? So now, after doing that, let's take a look at the question. They say, complete figure 17 by adding an ammeters and a voltmeter. You add an ammeter and you add a voltmeter. You already know, and they say you should use the correct symbol. You know, your ammeter is this. You know, your voltmeter is this. So easily, that becomes easy, okay? So your voltmeter should be in parallel with the wire, okay? And your ammeter in series with the wire, okay? So basically, you have to actually draw a typical diagram under, while you also indicate your ammeter and the voltmeter in these regards. They say, describe how the student would obtain the data needed for the investigation. Show your answer should include a risk assessment for one hazard in this investigation. So the first thing is that the length needs to be measured, okay? And the length also needs to be varied. And after current also being measured, the potential difference also needs to be measured, and this process needs to be repeated over and over. Then thereafter, you need to calculate the resistance for each of the length that's been measured. Then you now plot a graph of what? Of resistance against length, okay? That is how you are expected to go about this, obtaining the data and, determining, what is it called? how to obtain the data needed for the investigation. And one key hazard that one needs to actually take note of is high current in this regards. You have to be very, very careful of high current. Okay. And when there's high current, it can cause burns in that, in that regard. So that's one of the hazard risk assessment for one hazard in this investigation. The next question says, why would switching off the cycle between readings have improved the accuracy of the student investigation? And that is because the temperature of the wire would not change. The temperature of the wire would not change because of that. Okay, and the last one says the student used a crocodile clips to make connections to the wire. They could have used a piece of equipment that we call a jockey. Figure 18 shows a crocodile clip and a jockey in contact with a wire. You can see the diagram right here. How would using the jockey have affected the accuracy and resolution of the student result when compared to using the crocodile tip? Number one is that the accuracy of the student result will be higher. That's number one. The accuracy of the student's result will be higher. That's one of the effects of it. And secondly is that the resolution of the length measurement will also be higher. The resolution of the length measurement will also be higher. So this is the end of Paper 1, June 2018 AQA for physics. So in our next class, we're going to be looking at another paper in Paper 1 Foundation for Physics. That's going to be 2019 June in our next session. So do want to subscribe to this channel and look forward for more. Thank you for listening today. Have a wonderful day ahead. Bye-bye.